What we saw in the last video was how we can reduce radicals with negatives underneath the square root. Just like we can do reduction of square roots with a negative number, we can also add, subtract, multiply, and divide numbers that are called complex numbers. So a complex number is one in the form of a plus bi, where a is a real number, therefore it has no I with it, and bi is an imaginary number. We combine those together to get what we call a complex number. And again, this is called standard form of a complex number because it's the real number plus or minus an imaginary value. So what we're going to do now is see how to perform operations with complex numbers. So as an example, we're going to use x is 3 minus 2i. We're going to let y equal negative 2 plus 5i and perform the operations of addition, subtraction, multiplication, and later, in just a moment, division. In order to add, we're going to start by taking our 3 minus 2i and adding to it negative 2 plus 5i. In this instance, since we're adding, these parentheses are not really necessary. There's nothing that we can do in the parentheses, and there's no distribution required. So really what we need to do is combine our like terms. So we're going to combine the real numbers of 3 and negative 2. We're going to combine the imaginary numbers of negative 2 and 5i, giving us 1 from 3 minus 2, and negative 2i plus 5i is plus 3i. So this is our answer in standard form, the real number plus the imaginary part. To subtract, it's a very similar process. The difference is when we have a subtraction and we are subtracting a binomial, we have to be careful to distribute the negative to both parts within that second binomial. So what we really have is 3 minus 2i, and then a negative times a negative gives a positive 2, and a negative times a positive gives negative 10i. So combining the like terms, we get 5, and then negative 2i and negative 10i is minus 12i. So that is our solution to the subtraction of x minus y. Multiplication is going to remind us a lot of what we did when we started our discussion of quadratics, because we're going to take a binomial and then multiply it by another binomial. So some of you might think we'll be doing the FOIL process. Again, it's just distributing. So we're going to take 3 times negative 2, and that's negative 6. 3 times 5i gives plus 15i. Negative 2i times negative 2 gives us a positive 4i. And then negative 2i times positive 5i gives us a negative 10i squared. So this gets a little bit of a complex number. There's no room. But what is I squared? Well, if you remember from our previous video, I squared has the value of negative 1. So when we go to the product, replace the I squared with negative 1. That gives us negative 6 plus 19i, and then plus negative 10 times the negative I. So when we combine those like terms, we get 4 plus 19i, which is standard form for a complex number. So that is how we multiply. Now division is a little bit more complicated in the fact that we have to remember what we're dealing with. So what is I? Well, I is the square root of negative 1. And as we talked about yesterday when we were reducing expressions with radicals, we don't like to keep square roots in the denominator. Okay, so the reason why we have to do something special for division here is because this expression is not considered simplified because it has a square root in a denominator. We just don't write the square root, we write I. So as we saw yesterday, we would multiply the denominator by the conjugate. Well, in this case, since we have negative 2 plus 5i as the denominator, its conjugate would be negative 2 minus 5i. So we simply change the sign in between the two terms. This is a special case called a complex conjugate because we're multiplying complex numbers. So if we began with our simple division problem of 3 minus 2i over negative 2 plus 5i, what we have to do is multiply the numerator and the denominator of our fraction by the same thing. So we'll take negative 2, call that minus 5i on the top, and multiply by negative 2 minus 5i in the denominator. So now really there are implied parentheses around the numerator and the denominator in the first fraction, so that will remind us to distribute again. So here we'll take 3 times negative 2 and get negative 6. 3 times negative 5i is negative 15i. Here we're going to get a positive 4i, and from the last two terms here we get a positive 10i squared. So now in the denominator we take a negative 2 times a negative 2, and that's 4. A negative 2 times a negative 5i is positive 10i. 5i times negative 2 is negative 10i. And 5i times negative 5i is negative 25i squared. So the important part of multiplying by a conjugate is the fact that when we take that binomial times its conjugate, what happens is the two middle terms will cancel out. That eliminates all of the imaginary parts from our denominator. And again, what is I squared? Negative 1. So we're going to use that to simplify both the numerator and the denominator. So we'll take negative 6, negative 15 plus 4i gives negative 11i, and then plus 10 times negative 1. In the denominator we have 4 minus 25 times negative 1. So in the top we have a negative 6 minus 11i minus 10 over 4 plus 25. So now if we simplify again in the numerator, negative 6 and negative 10 give us negative 16, and then minus 11i. In the denominator, we would say that this is 4 plus 25, which is, of course, 29. So if we want to be very technical, to put this into standard form, we would break it apart into two fractions. Remember, if we have a numerator over one denominator, we can break it apart into each part of the numerator, or each term of the numerator, over that denominator. So this is our standard form of our quotient as a complex number.